Now, as we have seen the galvanometer in the previous lecture, that how and on what principle it works, and also we have seen the relation between I and alpha. Now we shall be understanding about the sensitivity of a galvanometer, right? Basically, there are two types of sensitivity of a galvanometer. As we could state it as the first one as being the current sensitivity of galvanometer. So this will be current sensitivity of this particular galvanometer, and the second one what we shall see is about the voltage sensitivity of the galvanometer, right? As we have seen that if we are passing a current through the galvanometer was deflecting, which means obviously that there is a meter scale reading which is or directly proportional to the amount of current that was passing through it. Now the galvanometer, let me tell you that it is actually a precision. Its precision level is very, very high. For example, if we are passing a very less amount of current in terms of ampere, it will actually detect that and it will deflect it. So the current sensitivity of the galvanometer, it could be said as, it could be denoted as alpha divided by I, which means that the definition for the current sensitivity of galvanometer is that the reading of the meter per unit amount of current as being passed. Now, as we have seen in the previous lecture, that I was simply equals to C alpha, where C was the constant. So we can see it as alpha divided by I will simply be equals to 1 divided by C. Now, as we have seen the formula for this C, we could write that alpha divided by I is simply equals to 1 divided by K divided by NBA, right? Or we can write that alpha divided by I is now equals to NBA divided by K, where N over here is basically the number of turns, as we have seen for that like rectangular type. B is the amount of the magnetic field intensity, and A is like the area over there, and K is the torsional constant, right? So we can say that the current sensitivity of a galvanometer, this particular thing, is directly proportional to the number of turns, is directly proportional to this B, is directly proportional to the area, and is inversely proportional to like this torsional constant. So if we are going to increase NBA and if we are going to reduce this torsional constant, obviously the current sensitivity of a galvanometer shall increase. Now let us come for the voltage sensitivity. Now the voltage sensitivity is basically defined as alpha divided by V. The definition of the voltage sensitivity is as such, like this voltage sensitivity of this galvanometer is defined as the meter reading change per unit voltage, and this will be simply equals to alpha divided by IR. As we know from the Ohm's law that voltage is simply equals to 1 IIR, right? So this basically is giving us the reciprocal of the resistance of that circuit multiplied by the current sensitivity of this galvanometer, right? So we can write it as, this was alpha by I equals to NBA divided by K, so we can write it as NBA divided by KR, where R is the resistance of this galvanometer, right? So from this particular thing, now we can observe that this voltage sensitivity of a particular galvanometer, this is basically directly proportional to the number of turns, again directly proportional to B, directly proportional to the area or the cross-sectional area of that rectangular frame, what we were discussing about in galvanometer, is inversely proportional to this torsional constant and is again inversely proportional to the resistance of this galvanometer, right? Now, as we have discussed in this lecture about the sensitivity of a galvanometer, in this current sensitivity with this, like this current sensitivity of this galvanometer, in the subsequent lecture we shall be discussing about that how we could actually use the galvanometer in converting it to as an ammeter, so as we could be able to rate the amount of the current which is flowing through the circuit. And likewise for this voltage sensitivity, we shall be looking into the subsequent lecture that how we could convert this galvanometer so as to make a voltmeter, so that we could actually measure the amount of potential difference in a circuit between 2 points. Thank you.